In this video, we will discuss steps in hypothesis testing. A statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. The null hypothesis, symbolized H0, states that there is no difference between a parameter and a specific value, or between two parameters. The alternative hypothesis, symbolized H1, states the existence of a difference between a parameter and a specific value, or between two parameters. Both hypotheses are used in each situation. The null and alternative hypotheses are stated together, and the null hypothesis contains the equal sign. Here are three sets of possibilities. First, the two-tailed test happens when we have H0 mu equals K, and H1 mu does not equal K. That is, there is some difference between mu, the mean, and K, but we don't know whether mu is less than or equal to K, less than or greater than K. The second situation, H0 mu equals K, that's always going to be the null hypothesis. H1 mu is greater than K, and we'll use a right-tailed test for this. We'll talk more about what that means in a little bit. And the third situation, H0 mu equals K and H1 mu is less than K. And we'll use the left-tailed test in that situation. For example, state the null and alternative hypotheses for each conjecture. First conjecture. A researcher studies gambling in young people. She thinks those who gamble spend more than $30 per day. So the null hypothesis is that the mean, mu, is equal to $30. The alternative hypothesis is that the mean is greater than $30. Mu is greater than $30. Second situation. A researcher wishes to see if police officers whose spouses work in law enforcement have a lower score on a work stress questionnaire than the average score of 120. So the null hypothesis is mu equals 120, and the alternative hypothesis is mu is less than 120. The third situation. A teacher feels that if an online textbook is used for a course, it may change the student's scores on a final exam. In the past, the average final exam score for the students was 83. So the null hypothesis is mu equals 83, and the alternative hypothesis is mu is not equal to 83. The teacher isn't saying that the mean will be greater than 83 or less than 83. It could be either way. After stating the hypothesis, the researcher designs the study. They choose the correct statistical test, choose an appropriate level of significance, and design a plan for conducting the study. A statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called the test value or test statistic. There are four possible outcomes when we test our hypotheses. First, we reject the null hypothesis when it is true. This is an incorrect decision and results in a type 1 error. Type 1 error is just that. We reject the null hypothesis when it's true. Second, we reject the null hypothesis when it's false. This is a correct decision. Third, we do not reject the null hypothesis when it is true. This is also a correct decision. And fourth, we do not reject the null hypothesis when it is false. This is an incorrect decision and results in a type 1 error, a type 2 error rather. The level of significance is the maximum probability of committing a type 1 error. This probability is symbolized by alpha. That is, the probability of a type 1 error is equal to alpha. The probability of a type 2 error is symbolized by beta. So the probability of type 2 error equals beta. It is often difficult to compute beta, but alpha and beta are related in that decreasing one increases the other. Statisticians generally use three significance levels, 0.10, 0.05, and 0.01. If the null hypothesis is rejected, there will be a 10, 5, or 1% chance of a type 1 error, depending on which level of significance is used. After a significance level is chosen, a critical value is selected from a table for the appropriate test. The critical or rejection region is the range of test values that indicates that there is a significant difference and that the null hypothesis should be rejected. The non-critical or non-rejection region is the range of test values that indicates that the difference was probably due to chance and that the null hypothesis should not be rejected. The critical value separates the critical region from the non-critical region. The symbol for the critical value is CV. A one-tailed test indicates that the null hypothesis should be rejected when the test value is in the critical region on one side of the mean. A one-tailed test is either a left-tailed test or a right-tailed test, depending on the direction of the inequality of the alternative hypothesis. In a two-tailed test, the null hypothesis should be rejected when the test value is in either of the two critical regions. Here's a procedure table for finding the critical values for specific alpha values using table E. First, draw the figure and indicate the appropriate area. If the test is left-tailed, the critical region with an area equal to alpha will be on the left side of the mean. If the test is right-tailed, the critical region with an area equal to alpha will be on the right side of the mean. If the test is two-tailed, alpha must be divided by 2. One half of the area will be to the right of the mean, and one half will be to the left. Second, for a left-tailed test, use the z-value that corresponds to the area equivalent to alpha in table E. For a right-tailed test, use the z-value that corresponds to the area equivalent to 1 minus alpha. For a two-tailed test, use the value that corresponds to alpha over 2 for the left value, and the z-value that corresponds to the area equal to 1 minus alpha over 2 for the right value. For example, using table E in Appendix A, find the critical values for each situation and draw the appropriate figure showing the critical region. A left-tailed test with A equals 0.10. The area closest to 0.1000 in table E is 0.1003. The corresponding z-value is negative 1.28. Here is our normal curve, the mean. Here's our critical value, negative 1.28. And here is the area in here, that's 0.10. A two-tailed test with alpha equals 0.02. Since the areas are the same on both sides, the z-values will be opposites. We find the area closest to alpha over 2 equals 0.02 over 2, which is 0.01, which is 0.099. The corresponding z-value is z equals negative 2.33 for the left value, and thus the right value is z equals 2.33. And here is the sketch. Didn't draw it very well the first time. I had to smooth it out. But here are our critical values and our areas. Find the area closest to 1 minus alpha equals 1 minus 0.05 equals 0.95. The closest values are 0.9949 and 0.9951, which are equally close. The z-values for these areas are 2.57 and 2.58. You may take the average, 2.575, or round to 2.58. I've rounded to 2.58 here. There's our area, there's our critical value. And finally, we have a procedure table for solving hypothesis testing problems. First, state the hypotheses, and identify the claim. Second, find the critical values from the appropriate table in Appendix A. Third, compute the test value. Fourth, make the decision to reject or not reject the null hypothesis. And fifth, summarize the results. We'll look into some specific tests in 8.2.